I want to start this talk with a question that may feel strange because, as you know, I've heard the talk is about federated learning. But I want to start asking you, how many of you use Google Gboard on their smartphone, on Android? Probably you're using it, but okay. Okay, and do you know how the models that are behind this keyboard are trained? Okay. Okay. We will see something about this today in this talk. The title of this talk is Learning Together Distributed, and I will introduce a little bit the idea of federated learning and how we can implement it and how this is used in some real-life use cases, such as the one that I just mentioned. I'm Luca, and I'm a PhD student at the University of Pisa, close to the end of the PhD. In my free time, I'm a podcaster. I have a podcast called Pointer Podcast, and I also help a couple of communities, one in Pisa. So before introducing federated learning, just a quick recap of how the classic machine learning works and to understand better what are the differences then with federated learning and why maybe we need federated learning. So when we want to train machine learning models, the first thing that we need to do is to have some data to train the model. So the first step is that we have to collect some training data. In this case, we have some cats photos, and so we have these images. We want to train a model, so we have maybe to put this data on a server, and in the end we have our model that will predict the color of the cat in the image. Usually, this is done, as I said, using an external server, relying on a server that is responsible both of aggregating all the data. So you have to trust this server, send to this server your data, in this case, again, images of cats. And then what happens is that the server will also will train the model at the end. So he will be responsible to train the model with the data that you send to it. So this approach has, obviously, it has some things that are really good, but there could also be some problems. So it is easier to train and also to debug because you have all the data in a single place. You don't need to take care of the fact that users have different kind of data, that this data is distributed among different locations, different devices. Around the training of these centralized models, there is a more mature ecosystem. There are more frameworks, more like debug tools probably also. And in general, you can find more resources online if you have any problems. The other important thing, since you have all the dataset aggregated in a single place, you have a view on the entire dataset. This can be particularly useful because you can understand at the very beginning of the training how your data is distributed, and maybe you can handle the problem that you would have in the dataset, maybe with some groups that are less represented than others. There are some problems at the same time because you have to trust the server. You have to trust that the server that receive your data will just use your data to train the model. And there are also some limitations because of some regulations. Like, for instance, in Europe, we have the GDPR. There are also similar laws that can somehow limit the data sharing, that can limit the data sharing between different countries, but also put some regulation on how the different companies has to handle the data. And there are also some scalability limits because you have to put all the data in a single place. So this company, as long as you have more data, you have to have more space to store the data, and maybe the models that you have to train on this data are bigger and bigger the more you have data. So what was introduced a few years ago to solve some of this problem was federated learning. This idea was introduced around 2016, 2017. The first time I heard about this was I remember I was watching Google I/O, and since this concept was introduced by Google, they were talking about this federated learning. At that time, I couldn't understand some of the things that they were saying, and then after some years, I started working on this topic. So the main idea is that instead of moving the data, that is what we have seen in the previous slide, we move the models that are trained by some clients, and I will call these clients nodes or users. I will use different terms, but basically these clients are the people that want to train a model, or they could be entities like, I don't know, hospitals or different companies. And then after you aggregate this data, after you move these models on a server, what happens is that you have to aggregate these models. As you have seen in the previous slide, the paper in which federated learning was introduced was published in 2017, if I'm not wrong, or 2016. But now, in the past 2 or 3 years, I've started to see more interest about federated learning. And I think that this is mostly because of 2 or 3 reasons. The first one is that probably we have more interest in some privacy problems that could arise when we share data with external servers. There is also more compute at the edge. Today, a simple smartphone can probably train a small model and share it with some external server. And there are also better tools to implement federated learning. When I started working on it around 3.5 years ago, I started working on some framework because I couldn't find a really good framework to use. And today we have a different solution that we can adopt instead of like reinventing the wheel every time we need to use federated learning. So just to see an example of what happens when we use federated learning instead of using a classic machine learning training. So in this case, we have, again, 6 different clients. All of these clients have some images, some photos of their own cat. And what happens here is that if they train their model only on their images, each of these users will only have some images of their own cat. So what happens is that the model will all be able to recognize a single cat. So what they could do is to move their data to a server, or the alternative solution could be to use federated learning. So in this case, you still have an external server, but what you move to the external server is not the data, but the models that you train. So basically what happens is that you take your data, you do some local training, and this is orchestrated by the server. So the server tells you, you have to train your model, you start the training, and then you move back the model to the server. This is executed one first time. Then the server takes these 6 models, in this case, and it has to aggregate these models in a single one. Usually, this process is done with a strategy that is just the weighted average of the weights of the model, and this algorithm is called federated average, and this is more or less the baseline algorithm for federated learning. There are some other strategies that you can adopt if you need to use federated learning. There are some strategies that, for instance, take into account the fact that some clients could be slower than others, but these are tailored for some specific scenarios. In general, you just do the average of the weights. And then what happens is that the server starts another round starting from this model. So the different clients, in this case, we have 6 clients. So the 6 clients will receive these aggregated models, and they will start another round training this model on their own data. This can be done for different rounds until you reach a certain accuracy of the model, or you could even continue until you want to train it. In this case, we had just a few clients, 6, but this can be extended to 1,000 or million of clients. I will show you now an example of, we can go back to the question I asked to you at the beginning. So the models that are behind the Gboard keyboard that is on the Android phones are trained with federated learning. And this was one of the first use cases of federated learning. This is another paper published by Google just after a few months, I think after the first one. And they explain how they were training the model to help users to have some suggestion about what to type using federated learning. So in this case, the different clients are the smartphone of the people using Android and using Gboard, and they were training, in this case, I think a recurrent neural network to predict the next token. During time, this thing evolved. So they started with simpler model, and then during the years they moved to something more difficult to train. In this paper, for instance, they were training a language model to help users again to have right predictions in Gboard. And they were not using federated learning, but they were also using some technique to improve and to guarantee more privacy to the users. Because I said at the beginning of the talk, I said that you have more privacy because you don't share the data. But even if you don't share the data, the model that you train is still could potentially still be vulnerable to some attacks. And for instance, in this case, they use differential privacy to avoid these attacks. This was also discussed in another blog post on the Google blog, and they were again they explain how they use the federated learning to analyze some data coming from the different users. And if you go to the web page about the Gboard, they explain to you what happens on your phone when you take part in this federation, and they also allow you to opt out and avoid that they train this model with your data. Another use case, again, it's another use case using a smartphone as a client. I don't know how many of you use Siri, but anyway, this one is another paper published by Apple. In this case, they use federated learning to train some speech recognition models using data that are on user device. So users don't share this data with Apple servers. They just train the model on device, and then they share just the model using federated learning. And even in this case, you can see they use differential privacy to preserve the privacy and to guarantee some privacy to the users. And if you want to know more about differential privacy, there are a lot of blog posts online, and I also did a talk last year at PyCon. I was mentioning the framework at the beginning of the talk. There are a lot of different solutions now to implement federated learning. Most of them, I would say, are more for research. There are, for instance, FLSim, that is a framework by Meta to simulate the federated learning. TensorFlow Federated is another solution by the TensorFlow team. These other, FedML, OpenFL, Federated Scope, are less known. There are also a lot of implementations. If you go on GitHub, you can find a lot of implementation of federated learning. Most of them, again, are just for research. If you need to propose something different, maybe you need to write your own framework, or at least to simulate something, writing a custom framework. The one that I use more or less every day is this one that is called Flower. I started to use it around a couple of years ago, and I did some research when I started to use it, and at that point, it was the best one among the other options. Now, I think that this is the... So I would really suggest you to start with this one if you have to start using federated learning. I like this project because it's an open source project. They have everything on GitHub, a lot of tutorials, a lot of examples that can be useful to start learning it. There is a nice documentation with, again, a lot of tutorials. And there is also a nice community around the project. Not only they have a Slack channel in which you can ask help about Flower and federated learning in general, but they also organize a lot of events around this framework. They organize a conference And if you go to their website, you can find all these talk that they gave at this conference. They invite people every month to present what they do with federated learning, and they also have some useful resources on YouTube to learn how to use Flower. It is a framework that is written in Python, and if you have to develop some components for Flower, you have to write them in Python. And in terms of the backend that you can use for the deep learning, there are different solutions that can be adopted. It is more or less agnostic with respect to the framework that you can use. You can use PyTorch, TensorFlow, JAX, and there are also other on their website with a lot of tutorials. You may, at this point, ask yourself, what about Android and iOS? They are working on it. There was an SDK that was developed for, it was an SDK that was taught to develop federated learning applications for Android and iOS. At the moment, it's not supported. And on their website, they say that this will be available in 2025. I was also checking for some JavaScript SDK because I wanted to do a more interactive demo for this talk, but they don't have it yet, at least the last time I checked. So Flower is also nice because they allow you to both simulate the training of federated learning models, but also to do the deployment. In my case, this was, so I always use Flower for simulations. For the simulation part, what it is nice is that you don't have to take care of how the simulation works. You just have to set some parameters, like, for instance, the number of nodes that you want to have, the number of clients that you want to have in the federation, so the number of clients that will actually train the model. You have to select what kind of data set you want to use, how this data set is split into the clients, and everything works without too many problems. On the other side, if you want to deploy it, I've seen that they have different tutorials on their website. They have a tutorial to deploy Flower on Google Cloud Platform, one for Azure, and they also allow you to create different Docker containers with the clients and the server to distribute your federated learning application. And we will see an example with Docker later. So the architecture of, in general, a classic federated learning application is composed by two main components. One is the server, and then we have the client. This is in general for all the framework. It's not specific for Flower. In the case of Flower, they hide some implementation around behind two main components that are the super link and the super node. So the server basically is split into two parts. One that is the super link that will take care of the communication with the different clients, and one is the server app. You will probably only touch the server app. So in the server app, basically you will have to write some logic of how the server works. For instance, you have to specify your strategy, how you want to aggregate the weights. In general, this is something that you don't change unless you have some specific requirement. On the client side, instead, you have the super node that is, again, the one that is responsible for the communication. And then you have the client app that is the place in which you define your client that requires basically one method to train the model and one method to test it. So the nice thing about Flower is that it hides the complexity behind the complexity of the communication. So you will not need to deal with the communication between the clients and the server. So I wanted to show you a demo of how Flower can be used. So I wanted to show you an example of how to create a simple Flower app. I will use the Flower command line interface. That is something that was released recently. for simple application, I think it's a nice way to start using Flower. Maybe if you need something more difficult, probably in the end you will end up in writing your components and without using the command line interface. But for this example, I think it's really nice. So in this case, I start creating a Flower app. So with the Flower run command, you can okay. Okay, yeah, because it's Flower new. Okay, I have to type the app name, my username, and then you can choose the machine learning framework that you want to use. In this case, we will use PyTorch. Okay, so can you see it? So now we have this new folder with the Flower app that contains some files and some other another folder in which we have our clients and server. Now let me just delete it, and I will copy there the one that I prepared for the demo. That is already ready for the tool. So, okay. I wanted to show you what's inside this one. So, in the PyProject file, you can find all the settings about the simulation that you want to run. Here, for instance, you have you define some setting about the number of training rounds that you will execute. So the number of time the server will select the different clients and will ask the client to train the model. This number here is the percentage of clients that are selected in the different training round. So in this case, we are selecting 0.05%. The 5%, sorry. And then we have the number of local epochs that the client performed during the training. And here, this number is the number of the clients that will perform the training. With the command that I used before, so Flower run, you can start a simulation. Yeah, I have to move to the folder. You can start a simulation. And now we will start it. Okay, so in this case, for instance, we selected 2 of the clients, and we had 20 clients in total. Now it is running the training. In the meantime, I wanted to show the other parts of the app. So in the task file here, can you read it? So we define some methods and some classes that can be useful during the training. We have the definition of the neural network that we are using. We define the data set that we are using. In this case, we are using MNIST. So the task is to classify basically digits. And we also define how we want to partition the data. Since this is a simulation and we are using a data set that is not taught for federated learning, we are just splitting this data into 20 parts. In this case, in an ID manner. So this file just contains some additional function that can be used, for instance, to train the model, test the model, nothing else. These two functions are used by the clients when you receive the model from the server. When you receive the weights of the model from the server, you then have to put these weights into your model, and so you have to define these two other functions. We have 2 additional files here. One is the server, and here you can find the definition of the strategy that you want to use in the server. In this case, is fed average, and you pass here some of the parameters that we defined before, like the fraction fit, for instance, the percentage of clients that will be used during the training. And in this case, this is instead the number of clients that will perform the test. And this is the server. Last thing I want to show you is the client. It's nothing too difficult here. In this case, you just have to declare two functions. One is to train the model, one is to evaluate it, and then you have just to declare your client. And we can go back to our training here. In this case, so I don't have the accuracy here, but we can see that the loss is decreasing during the different rounds. And this one is, again, an aggregation of the losses of the different clients. So it's like an average of the losses of the clients. And we can see that we are somehow learning something. The nice part is that with using this command line interface and using this configuration file, I can put here any number of super nodes. I can start again the simulation, and then in this case the dataset will be split into 500 clients instead of 20. And I have to say that they did a great job in under the hood to manage all these the training in parallel in the different clients. So even on a laptop, you can still run the simulation even if you are running 25 clients in parallel. So I can stop it, and I wanted to show you one last thing in the demo. I've said to you that you can also create some. You can also run the clients and the server in some Docker files, some Docker containers. So in this case, in the original PyProject file, we were asking Flower to run the simulation on our device. But what you can do is also to add some. Oh, just 1 second, sorry. You can also specify some additional parameters about how the server is located, basically. In this case, we are saying that we have this server listening on this on this port, and I've created a simple script to run the different Docker containers. This is something that I usually don't do because I mostly do simulations, but I prepared this because I wanted to show that it's also possible to run this Flower in multiple machines and in multiple Docker containers. What we need for this simulation, for this test with the Docker containers, is a super link that, if you remember, is the one that is responsible for the communication. We need a super node, one super node for each of the nodes that we want to create. So we have one server, and then we have 5 super nodes. So we will have then 5 clients that are these ones here. And if I run these, hopefully it will work. Let me see if. Okay, let's see if it works. Okay, so the containers are running now. And what we can do is to ask Flower to run these new simulations that is run with these clients in the container and with the server in the container with a different flag when we run it. So instead of using Flower run, we have to say we have to add deployment here. That is the name of this additional setting. And stream is just an additional parameter that we can use to see more details about the execution. So in this case, the server is in this Docker container, and we have 5 Docker containers also for the clients. So you can see that in this case we have 5 clients, and we are selecting 2 of them, while here we have 500. So we are using this second branch for the execution, basically. Okay, so I can go back to the slides for some final considerations. So just to summarize what I've said. So there are mainly the main difference between centralized learning and federated learning is in where the data located, basically. In the case of centralized learning, all the data is in a single central server, in a single location. Federated learning is more respectful for the privacy of the user, because they don't need to share their data. So in this case, the raw data never leaves the different devices. This can be useful specifically for some regulations, and from what I've seen, this like federated learning is used mostly in some scenarios where people are really interested in not sharing the data, like for instance in healthcare applications. I've seen that different startups are using federated learning for this in this scenario. I would say that in terms of learning materials, tutorial, and in general also framework, if you want to start training some like classic machine learning, centralized learning models, you can find a lot of tutorials, a lot of framework. With federated learning, nowadays there are more and more tutorials, and it's easier to start working on it than it was 3 or 4 years ago. Some other considerations that are worth to discuss. The first two are important if you run federated learning application in real life scenarios, because you have to deal also with clients that decide to stop doing the training. You have to deal with some latency that is maybe because of the network. It could be because of maybe some clients have a smartphone that is cheaper than others, so maybe they have like they stop the round. You have to wait for some clients basically because some of them are faster than others. These are in real life scenario, and as I was saying before, there are solutions that try to solve also this problem, like asynchronous federated learning. The last thing is a problem that you have both when you have to simulate the federated learning training, but also in real life scenarios. You have to deal with the fact that users are different. So people maybe that are located in some parts of the world could have different data that people that are located in a completely different part. So you have to deal with underrepresented groups of clients. You have to deal with models that maybe start to treat user differently. So this is a problem that is still present in federated learning, but also in the classic machine learning. And I've worked on a little bit on this part of fairness and the training of federated models. If you want to learn more about federated learning, I would recommend starting with Flower. I don't work with them. I just really like the framework and this project. They have a lot of tutorials on their website, and they also have a nice playlist on their YouTube channel in which they presented all the things that I discussed today in like with more and more videos, and in like trying to understand better what are the different parts of the framework. Some things to conclude. I've seen that during these last years, there is more interest in data privacy, and so also in federated learning, especially in some sector, as I said, in the healthcare one. I think that this can be one solution to deal with this problem. If you are thinking about this, even bigger models can be trained using federated learning, even a large language model. There are some examples of these, again, on the Flower website. They not only they train as a large language model with 1.3 billion parameters, but they also presented like some tutorials to fine-tune large language model using Flowers, and they have I think some resources also about how to do this. One last bold statement that was written on the bags that Flower team gave us when we went to the conference. They think that the future of AI is federated, and I mostly agree with them, because all the data that we create and all the scalability problem that we could have with all this growing amount of data could probably be solved using a distributed and decentralized learning. So this is the end of my talk. Thank you for thank you, and if you have any question, I'm happy to answer.
Thank you, Luca. So there are some questions here in Slido. The first one is the advantage of going federated related to energy, lower overall cost, time, it takes less time to unite many models, or something else?
So in terms of time, and also in terms of how difficult it is to train the model, I would say that if you run the centralized learning, you can be faster in the training, and you can probably obtain a little bit better results. There are studies and papers that studied like what are the differences of training models with federated learning and centralized learning. In the original one, they compared the training of two models, showing that there was a small difference in terms of accuracy. In terms of energy, from the point of view of the company that has to train the model, they are probably happier to use federated learning because they don't have to train the model on their own server. You will have to train it. On the other side, they will not have your data, so there is a trade-off. And I don't know if there are other parts of the question.
No, they just ask if there is something else that is an advantage.
From the user point of view, the main advantage is that you don't share the data, and from the
privacy.
Yeah, the privacy. Yeah.
Okay, so the second question is, what happens if someone sends a worse model, for example, a model trained on images of dogs? Can you intercept this?
So there are studies on this, and it's called model poisoning. And in this case, so it depends a lot on the scenario, because even if you send like a malicious update, if you are in a scenario in which you have like millions of clients, maybe you are selected today for the training, you send your malicious update, and then you are not selected for the next 6 months. So your update will be basically useless in the end, and you will probably be less important than the others. This can be at the same time a problem, because if you are not malicious but you just have a different data distribution, this could be a problem. So there are some studies that study some papers that study how to deal with these model poisoning solutions, but as far as I know, there are no real solutions that solve this problem. Because if you, for instance, if you receive some models update and you say, okay, this one has a different like weights distribution than the others, it could be because it's malicious, but it could also be because it has a different distribution. If you decide to not to use that model in the aggregation, you could avoid aggregating one model that is malicious, but you could also aggregate a model that comes from a user that is just a different user than the other. So you could have, for instance, fairness problem at that point.
Okay, thank you. So I lost a question. Okay, probably there was a question, but I lost it, so I will read this one, and then if there is someone with a question, I can... Okay, so you deleted. Okay, thank you. So the last question is, in your opinion, do you think that federated learning is better for data privacy rather than using synthetic data to anonymize raw data?
So this is a nice question. I'm not too expert on the synthetic data part. I know that there are some different opinions on this, on how, if the creation of synthetic data is guarantees some privacy to the users or not. So I don't know exactly what to say here. There are I know that there are some papers that also studied how the synthetic data if synthetic data are really privacy preserving or not, but I don't know too much to answer this one, sorry.
Okay, so the very last one. Can you flag users in non-ID federated training by demographic, like separating Italian and English Gboard user for training? Speaking of which, is there research on a mixed approach using both federated and centralized data?
So for the first part of the question, in theory, if you know this information about the user, you can already infer some information that you shouldn't know about the user because you know the distribution of their data, and in theory you shouldn't know the distribution. There are some way maybe to share some information about the distribution of the data of the clients using, for instance, differential privacy to preserve their privacy. So in theory you shouldn't know the distribution of the data. And the second part, again, sorry.
The second part is there research on a mixed approach using both?
So the thing that I've seen is that in some cases, some data is used on the server side to maybe pre-train the model, but in this case, you assume that you have some like external data that is not coming from the user, but is maybe data that you can find online. But in general, the constraint you have with federated learning is that you don't share the raw data of the clients, and you shouldn't also share information that could reveal something about the clients that you didn't know before starting the training, basically.
Okay, thank you, Luca.
Thanks, thank you.